first the activity series, just because it'll allow us to generate equations. So we're going to look at the table in the back of the book, which has reduction potentials. Okay. So in your data booklet at the back of the table, we've got reduction potentials of half cells. We're not going to worry about the volts here. We'll talk about that later. But we list them as oxidizing agents or as reduction reactions. Reading left to right, you're gaining an electron, so that's a reduction. Strongest ones are at the top, so fluorine would be the strongest, which kind of makes sense because it's the most electronegative, so it wants electrons. And if you look at the very bottom, you got your alkali metals. They are the weakest because they want to give up their electrons. So they are strong reducing agents because they want to give up electrons. That's the reaction when you dump sodium in water. If you put sodium metal in water, what it does is it dumps an electron onto water, produces hydrogen gas and sodium hydroxide. That's what happens. Water is losing in electrons, it's oxidized, and it caused the water to be reduced. And that should be hydrogen gas, not water there. H2 gas. And it's an exothermic reaction which ignites the hydrogen gas, and you get a boom. Okay, so how do you so certain things, some such as copper, can gain or lose an electron, which, as you can see in the table, copper, the hardest part about this table is finding things on it. So copper there it is right there. Okay, so copper can pick up electron to become copper solid, or can donate electron to become copper 2. Okay, so there are things that can gain or lose an electron. I talked about this. The reactive metals are strong reducing agents. Those are the alkali metals and the alkaline metals, alkaline earth. And then the halogens, because of their electronegativities, want electrons, so they want to oxidize things. They're the strongest oxidizing agents. Okay, so what does this table allow us to do? It allows us to predict whether a reaction will be spontaneous or not. So, for example, if we have silver, okay, any oxidizing agent, i.e. the left column, will spontaneously react with any reducing agent in the right column that is below. Okay, so if we have silver, there's silver. Okay, silver ion will react with any of these going down, any of these things on this side. Okay, below it. So anything above on the left will react with anything below on the right. And that will be a spontaneous reaction, for example. So it will react with iodine, I minus, but it will not react with bromine, Br minus, which is right there. So silver and iodine will react, but silver and bromine will not be a spontaneous reaction. Okay? And that's all the notes are saying right here. It reacts with iodine, but not bromine. Same with aluminum, will react with magnesium, but not manganese. And aluminum, it's right there, will react with magnesium metal, but not manganese metal, because that's above it, but anything below and to the right. So you kind of up here, and then anything on this side and down below it will react spontaneously. The other thing, I'm not going to worry about this bit. It's just saying it in the reverse order. So we're just going to go with the oxidizing agents. On the left, will react with anything below on the right. But this is important. No two species in the same column can react together. Okay, so for example, if I have lithium and cesium ions together, there will be no reaction because they're in the same column. All right. But cesium will react with lithium metal, but not the lithium ion, because neither one will want to give up an electron. But this reaction will be spontaneous, so cesium plus an Li solid, that is spontaneous. But Cs plus Li ion, or positive, will not be. Okay? All right. So we're given the following. We're given zinc ions and zinc metal and nickel ions and nickel metal. Which combination of these two will be a spontaneous reaction? Well, let's find the metals. Or sorry, the ions. Zinc and nickel. So zinc is right there. Nickel. No, there it is right there. There's nickel. There's nickel. Okay. So zinc ions and nickel ions will not react because they're in the same column, but nickel will react with the zinc metal. Okay, so to write that reaction, nickel and the half reaction as written on the table looks like this. The table writes the reductions. But we know from our balancing that the electrons have to cancel. And we just said that nickel 2 will react with the zinc metal. So we're going to flip this reaction. The atom that is ionized, or the molecule that is ionized, you flip the reaction to write it out. So the actual reaction of this is going to be nickel plus 2 electrons plus zinc solid will go to zinc plus 2 plus nickel solid plus 2 electrons. And I know I'm just writing the electrons to show that they cancel, and we know that the electrons always have to cancel. So it's nickel 2 plus zinc solid. And that's the actual reaction. The oxidation, and that's what this says right at the bottom here, the oxidation reaction is always flipped. Okay, because the electrons have to cancel. If something is being reduced, something has to be oxidized. So it has to give up the electrons. All right, the next reaction, will this be spontaneous? Well, let's just look at these two things here, copper and zinc. Copper solid and zinc. And it's going to copper 2. So zinc 2 is right here. First of all, you can just look. Zinc 2 will react with anything that's below it on this side. Copper is not there. Copper is up there. So that's the wrong side, copper solid. So this is not a spontaneous reaction. And that's because the copper solid is not below it and to the right. That's the sort of simple way to look at it. There is another way to look at it. If we write up the reaction again. And you look at the copper and the zinc ions, these two. These are the reducing agents, oxidizing agents. Okay, because they want to gain the electrons. So if you just look at this reaction, if you have it written out, and you locate zinc 2 and copper 2 on the table, zinc 2 is right there, copper 2 is right there. We just said that it lists them. The higher up on the left, the stronger you are. It's like acids and bases. So it's a battle between these two. Well, copper 2 is a stronger is stronger than zinc 2. So that means this is stronger oxidizing agent. So it pushes the reaction that way. The reverse reaction will be spontaneous. Okay, so it's a battle between the two oxidizing agents. That's another way to think about this. Whoops. Copper 2 is stronger away than zinc 2. Therefore, the reverse reaction is spontaneous. Okay, so that's all we're doing for now, is we're trying to figure out if a reaction will be spontaneous or not. If you are if you are on this side, it will react with anything below it on the right. Okay, or if you have two oxidizing agents, you can just look at them, whichever one is higher on the table. So that's the copper, the zinc 2, and the copper 2 that we looked at. The higher one will be win the battle, and the reaction will proceed in that direction. Okay. Please do the questions assigned at the back here. If I can find it, there we go. Sorry. Please do these questions. All right. You're just saying whether they react spontaneously. A couple here, you'll have to list which are the strongest and which way the reaction will proceed. Other than that, I think it's okay. I'll post the key, and I'll see you in a couple days. Thanks, people.